In this video, we have to understand about the kubescaler and controller manager. And this video is the continuity of our how multi-master failover works. We understand in the previous video about etcd complete architecture and its failover in the multi-master setup. We understand about the API server, how it's acting in the multi-master cluster setup. So the next two core components are kubescaler controller manager. So these are the four core components that are running on the control plane. So how does kubescaler and controller manager leader election happen? Understand the leases API resources. And how does the kubescaler controller manager use the load balancer to connect with the API server? And to understand this concept, we will perform a lab for the scalar and controller level of failure. So let's start. I have my Kubernetes cluster. First of all, we will look into the pods health on our kube system namespace. So what pods are exactly running right now? So we can see the four controllers are working perfectly fine, and four scalar are running in the cluster. And but the thing is, only one controller and one scalar is actively participating in the cluster. Um, you can say management. So if I do a kubectl API resources, and here if I just do a grep to leases resource. So this is a built-in Kubernetes resource, and this leases resource is by default created. If I search for the leases resource hyphen and in the kube system namespace, so we can see the leases resource for the controller manager and scheduler is created. So let me just do a describe to these resources in this namespace. So here we can see the holder identity is master 3, and in the logs we can see about 12 minutes ago some election happens, and the leader election happen among the controller managers, and master node 3 wins that will actively participate work in the cluster, and rest of all will be passive. And same if we do the describe for the scalar resource of leases. So here we can see the holder identity for the scalar is master node 3, and in the last election master node 3 scalar wins and elect, selected as a leader. So in this case both are same, but it can be different. You can see in the logs previously it was different. So when the election will happen, whenever the leader will fail, the election will happen, and there is no hard and fast rule. Just like the etcd, we understand the minimum required number of the quorum members to perform the election. Even if there is a one scalar or controller left, it will perform the election, and it will pass itself as a leader. So even there are two, three, four, whatever numbers of these controller manager scalar are there, they will do the election and they will select. So now if we do the failover, for example, I know right now both are running on master node 3. So I will jump on my master node 3 under the Kubernetes and manifest directory, and I will just shut down the controller manager and scalar, and I send both to the temp. And let's now again describe the controller, and right now you can see still master node 3 controller is up. It will perform the election as soon it will go down. So let me describe again. So 9 seconds ago we can see the election happens, and the master node 1 has been elected to actively participate as a controller manager in the cluster. Same we will do for our scaler. Scaler, we can see the 50 seconds ago the election happened and masternode 4 has been elected for the leader. So this was the concept about the leases resource and about the election process of these two resources. So far we understand about the API, the etcd, scheduler and controller. And if I just conclude, we found that only one etcd, one scheduler and one controller is actively participating in the cluster. And all the API server are actively participating in the cluster. So now we have understand this. Now we will look into the concept that how does these two components are connecting with the API server. So if we go to our cluster and we look into the Kubernetes manifest and we just do some open this file controller manager. So in the controller manager we can see there is a kubeconfig file used by this controller manager, and this kubeconfig file is used to connect with the API server, just like we as a human are using the kubeconfig file. Similarly, some system user is created, some service account is created, and that is used by this controller manager.conf file. We understand this in detail in our previous videos. So some role-based access controls are given there, and this controller manager is connecting with the API server. And in fact, if we look into the image that is responsible for whole this operation. So this pod is using this kubeconfig file, and if you go down, we can see here the volume, and one of the volume is acting as a kubeconfig, and this is the kubeconfig actually placed on our master nodes, and here it is mounted inside this container with the same name, and the same file is used by this controller manager binary, and these are all the arguments associated. So let's go to our master node back. I will just close this file, and I'll do cat to this file, and we can see this is the same like file. It is using the CA certificate. It is using the server, the API server as a load balancer IP. Just like we are using the load balancer IP to connect with the API server, same like this is communicating with the API by using the load balancer IP. Because we understand that all the APIs will be active, even we left one API active, the cluster will work. So to avoid any failover, we have not used the local API server for the controller manager. We set up the load balancer IP to connect with the API server. And these are the client certificate data. It is used by this user that is by default created when you spin up the cluster. And this user definitely has some role-based access control and role access control and role bindings. You can dig down this user, but here we have to understand how it is connecting. So we see it is connected. So all, if you go any of your node and do the cat to this file, so you can understand all the controller manager are using their own config file, kubeconfig file, the same file, and communicating with the load balancer to talk with the API. So Now I will open this diagram the Kubernetes architecture diagram that we showed you in very first video of the Kubernetes installation. And when we understand the architecture of the Kubernetes, we can see here the API server is there. And here the arrow is going to the controller and scaler. Why the arrow is going to controller? Because the controller is getting some information from the API. This arrow does not mean that API is trying to communicate with the controller. In fact, this arrow should be on the both side. First of all, controller manager and scaler both will use the kubeconfig file that I showed you, will try to communicate with the API server and will make a tunnel on this 6443 port that is used by the API server. And then whatever changes will happen by the API server will be acknowledged by the controller and scaler. So let me now show you how does the same thing is happening for the scaler. So let's go to the manifest location and cat to the scaler file, and here we can see the kubeconfig file is also used by the kubescaler binary, and the command ran inside the container, and this is the image used. And this file is same like I showed you for scaler. On our host machine this file is available, and the volume is mounted inside the container, and container is using for its kubeconfig. So if I go to back to my node and do a cat to this kube scaler.conf file. This is the kubeconfig file used by the scaler to communicate with the API server, and here the IP is also set for the load balancer. This will automatically be set to the load balancer when you will set up your Kubernetes cluster for multi-master. And it is using some kubescaler user, and this is the public and private keys used. So if I go to this diagram, the scaler is also talking with the API. But why the arrow is on the opposite side? Because controller and scaler both are fetching the latest update from the API server. There is some, we can say, some watch time is running inside these controller and scaler. When they will start, they will make the connection to the API server, and all the time they are in contact with the API server. And whenever some change will happen, so the watch, we can say some scaler or some cron job is running inside these two component, and they will look into any new change happen by the API server. So then they will acknowledge back to the API and they will perform their action. So this is the process we understand that how does they are communicating with the API server. So now we cover all these four components. This arrow that is going to the etcd, the API is always communicating with the etcd. Rest of all controller and scaler are looking to the API server. And the load balancer is actually making the failover for the controller and scaler. All the traffic for the API is going out to the cluster, and from outside the load balancer is then routing the traffic to the API server, so that any of the control healthy API server could answer in case of failure of the single API or any node. So so this was the concept. We performed the lab with the failure, and in the next video we are going to understand the last component, that is the kubelet, why it is running on all the nodes and what is the purpose of this kubelet and how it is communicating with the API server. So this was just the agenda for this video.